Hello everyone, welcome back to another session of discounting method. In the previous video, we talked about the net present value. The net present value is one of the discounting investment appraisal method. It takes into the consideration of the interest rate, the inflation rate, and even the risk of the project. Considering the money in the future is going to worth less than the money today, the net present value actually apply a discount factor to the money in the future and try to estimate what is those money going to worth in today's term. The NPV is calculated by adding up all of the future cash flow and divide this by 1 plus the discount factor or the interest rate or the inflation rate and raised to the t power where t represents the number of years. In today's video, we are going to talk about another discounting investment appraisal method, which is called the internal rate of return or the IRR. If you look at the formula of the IRR, you will see that the formula is actually look pretty similar from the NPV. The only difference is that this here, instead of R, we replace it with the IRR. And in here, instead of any random number, we want to replace this with a 0. Basically, what it means is that based on the future cash flow that we will receive in the future, we want to divide this by 1 plus the internal rate of return, and we want to raise to t, which t represents the number of years. And in this case, we are going to adjust the IRR so that the number or the answer will equal to 0. If we are comparing two or more different projects, then we will choose the one with a higher internal rate of return. Both IRR and NPV are very popular investment appraisal methods. They are widely used in practice and they are very easy to understand. Same with the NPV, it will estimate the cash flow of the entire project, and plus another benefit of IRR is that it does not really depend on what will be the interest rate in the future. So let's have a look at the practice question for the machine A. In order to invest in the machine A, first we need a cash outflow of an initial investment £750,000. And because today, year 0, there's no any cash inflow, then therefore our net cash flow will be a negative £750,000. For the cash outflow, assuming every year we are planning to spend $7,500 in Facebook advertisement to generate revenues. And following this strategy, we'll be able to generate a revenue of around $150,000 and up to $300,000 in year 5. The net cash flow can be obtained by subtracting the revenue or cash inflow by the expenses or the cash outflow. And therefore, in this case, in year 1, it will leave us $142.5 thousand. Year 2, it will be $200,000 minus $7,500. It leaves us $192.5 thousand. In year 3, it will be $260,000 subtract by the $7,500. This leaves us $252.5 thousand for year 3 and year 4. And for year 5, the revenue is $300,000 minus the expenses of $7,500. Then this will leave us with a net cash flow of 292.5 thousand. The question is how to find the value of the IRR for this machine. Again, if you remember, the formula of the IRR is to sum up all of the future cash flow and divide this by 1 plus the internal rate of return and raise to the t power, where t represents the number of years. And we want to set the IRR so that the NPV will become 0. In the exam, if the student see the IRR question, then generally they have to calculate this manually. It means that the student will require to estimate what is the number of the IRR so that they can get an answer of 0. Now, in our previous video, we know that at the 10% discount factor or the interest rate, we still end up with a positive NPV. So in other words, the discount factor will be higher than 0 so that when we discount this, the number will reduce to 0. If we put 20% and the answer become a negative number, then we know that we have to reduce the IRR. And if we try 15% and then the number is still slightly below 0, then we know we have to adjust it even further. So next step, we try 14% and apply into this equation. Considering the time constraint, in this video we are not going to do the 20 and the 15%, but students can give it a try. It will end up with negative 0. And in this video we are going to try 14%. Therefore, the initial investment is 750,000. We do not need to discount this because this is the amount of the initial investment that we have to pay today. For the first year, it is going to be the 142.5 thousand, and then divide this by 1 plus the IRR and raise to 1 because this is the first year. And for the second year, this is going to be the 192.5 thousand of net cash flow, and then divide this by 1 plus the IRR and raise to square or second power because this is the second year. For the third year, it is going to be the 252.5 thousand, and then divide this with the IRR, 1 plus IRR, and raise to the third power because it's year 3. And year 4, it will be the same 252.5 thousand, divide this by 1 plus IRR and raise to 4th power because it's year 4. And for the 5th year, it is going to be 292.5 thousand, and we want to divide this by 1 plus IRR and raise to 5 because it is the 5th year. In this case, assuming we already tried, the 10% is too small for IRR, 20% is too big for IRR, 15% is still too big for the IRR, so we will reduce it once again to 14%. And in this case, it will be the initial investment of negative 750,000 plus the first year we got 142.5 thousand. Divide this by 1 plus 14%, and then for the second year it will be a net cash flow of 192.5 thousand. We want to divide this by 1 plus the 14% and raise to the second power. Third year is going to be 252.5 thousand. We want to divide this by 1 plus 14% and raise to the third power. Fourth year is going to be 225.5 thousand. Divide this by 1 plus 14% to the fourth power. And the last year is going to be 292.5. Divide by 1 plus 14% and raised to the 5th power. And if we put this into the calculation, then we will get a NPV of nearly equals to 0. If students want to be more accurate, you can try 13.75%, or if you want to go even further, you can try 13.7508%. Then you will get an NPV that is even closer to 0. To finish this question, I would like to leave you with a IRR practice question for machine B. So for the machine B, assuming the initial investment is going to be 310,000, where every year we are planning to spend 15,000 pounds for the Facebook advertisement, and this will help us to generate a revenue of 125,000 to up to 140,000. What students need to do is to calculate the value of the IRR and concludes that whether the machine A or the machine B is a better investment. As usual, don't forget to save your answer in a PowerPoint format and submit this to the StudySmart as it counts as your attendance. Hopefully by now, when students see a symbol of 5% or 10% IRR or in the banks or in the projects, they will now understand what IRR or the internal rate of return actually means. In this case, that will mean that if IRR is 5%, then every year it is earning a 5% compound interest rate. And if it's a 10%, then that means every year it is earning a 10% compound interest, where the interest also earned an interest. And in the previous example where we have in the machine A, we will see that every year that project is actually generating 13.75% of the return. Once the students submit their work for the IRR practice question, then I'm sure the student will have a better understanding on how to calculate the internal rate of return. But for now, I would like to thank all of the students for watching this video, and I will see you in next one.